The topic, guys, is solving systems by substitution. The first example we have is to use substitution to solve a system of equations with no solution. This system has no solution. So it says that Gemma sells tickets at a local fair. On Saturday, she sells 800 tickets and collect a total amount of money of $7,680. So we need to know how can Gemma determine the number of each type of ticket that was sold on Saturday. In the reasoning, the little advice you have below, they give you information. How can you use two different equations to describe the relationship between tickets for adults and the children ticket? We are going to relate. We have the total of tickets, that is 800. So if we identify one value for the other one, for example, the number of adult ticket, we can obtain the value for the children. The same if we do the opposite. If we first obtain the value for the children, later we can use this value to subtract with the total and find the value for the other variable that you are going to have, okay? Because remember, we need to have two variables, okay? So we can solve this in the step 1. We write a system of linear equations to represent this. So we are going to write the system to represent this part. Okay. So what is the system that we are going to have? For the first one, the children ticket. So we are going to use one variable, C. If we replace for the system, the first variable is C plus the variable A, that A is going to represent for the adult. So we have the adult ticket. This is going to be equal 800. Remember that the total of tickets they give you, they are 800 tickets. Okay, then what is the next step? In the first equation, I'm using the number of tickets. And in the other one, I need to use the amount of money that she is going to obtain. So she obtained $7.50 for each children ticket. So we multiply by the variable C that is represented for the children, plus 13.50. Remember, this is representing what? Representing the price for the number of adult tickets, okay? So the price for each adult ticket. And this is going to be equal $7,680, right? This is the two equations that we have. This is our system of equations. We have two equations to solve. This one is the amount collected for children ticket, the amount collected for adult ticket, and the total amount collected of money, okay, for this, for selling the tickets. So in the step 2, we need to solve for one of the variables, and we need to choose what variable we are going to use. And what equation? For example, for the first one, you only have the variable C and A. You don't have anything multiplying your variables, like in this. And you have the 7.50 multiplying, and you have the other one, the 13.50 multiplying the other variable. So we are going to use this equation to find the value for one of the variables. But the value is not the real value, it's an expression that we are going to use to find the value. So if we copy C plus A equal 800, we are going to find for what variable. In the book, they solve for the variable C, okay? So we express the terms into the variable A. So if we solve for the variable C, we have that C is equal 800 minus 8. So the number of tickets, the total number of tickets, but you subtract the number of tickets for the adults, then you have the number of tickets for the children. Remember, I'm using the total because I want to know the value for both of them. I want to know how many tickets for children and how many tickets for adult people they are. Okay, so in the other part we have, when we find this, we need to substitute in the equation to find the value. Okay, so in this part we are going to replace. We obtain that C is equal this, and I'm going to replace this into the other equation. This is the value for C, so I'm going to change this value, okay? When we are solving system of equations, guys, the idea is to not work with both variables. I'm looking for one way to work with only one variable, so we can solve first for one of them, and later we use the variable with the value that we obtain to find the other one, okay? This is the idea of this. So yeah, if I have the equation 7.50C plus 13.58 equal 7,680, I'm going to erase this part. I'm going to erase this part so I can show you. 7.50 multiplied by C, that you know that C is 800 minus 8, okay, plus 13.58 equal 7,680. Okay, and then we are going to do the same like we solved in the other part of the examples, remember? The number that is outside the parentheses, I'm going to multiply it by all the numbers and variables that we have inside. This is 1A. I don't know why this doesn't look correctly. It's 1A. Then we start multiplying. I'm going to copy the result for the book so we don't lose time multiplying. When you multiply 7.50 times 800, you obtain 6,000. Minus 7.50 multiplied by the variable A, 7.50, 8. Plus 13.50 A equal 7,680, okay? 7,680. And remember, I only write together the terms that has a variable, and I solve the operations, addition or subtraction. And later we have the other terms that doesn't have any variable to solve. So in this case, for example, I have negative 7.50 A plus 13.50 A equal 7,680 minus 6,000, because in here I have one addition. So I pass this number to the other side with negative sign. So minus 6,000. And what is the result for this? 13.50A minus 7.50A is going to be equal 6A. And this is going to be equal 7,680 minus 6,000, that is 1,680. Okay. And what is the last step? The number 6 that is multiplying your variable A is going to pass to divide to the other side. So finally, we obtain that A is equal to 280. So the number 280 is representing what? It's representing the number of tickets for the adults, okay? The number of adult tickets. Remember that this is for the adults. And we are going to use this to find the value for the children tickets. So I need to erase in the board, guys. I'm going to erase this part.
Mister. Mister, don't erase the. I have a question. I get lost at part where it says 6A equal 1,000.
This part.
Where did you get 6A?
You pass the numbers that has the same variable. Okay, you have negative 7.50 plus this one, and I pass the 6,000 to the other side with the numbers that doesn't have any variable, and I solve. The numbers that have variable are these two, so you subtract negative 7.58 plus 13.50, you obtain 6, okay, 6A. I only associate the numbers that have variable with the numbers that have the same variable, and later apart I solve for the numbers that doesn't have any variable, like these two, okay? And at the end you only pass the number that is multiplying your variable to divide. In here you divide 1,680 by 6, only that I don't write the last step because of due to the space that I don't have more space to write it, okay? But this 6 that is multiplied, you pass it to divide this quantity to obtain 280, okay? So
okay,
I don't know.
Thank you.
Okay, if you have to clear that part. Okay, then I only substitute this value that we obtained to find the value for the other variable, okay? So, okay. We continue then with the last part. In the last part, it's only to replace, remember that A is equals to 280. And we have the equation that C plus A, I think that, yes, C plus A is equal 800. These are the two equations that I have at the beginning. And I'm just replacing. If A is 280, I have that C plus 280 is equal 800. And what are you going to do if you have this number that is in addition? You want to find C, so you want C to be alone. When you need to isolate the variable, you want this to be alone. So you can pass this number that is in addition to the other side to subtract. And you have that C is equal 800 minus 280, okay? And this is the result. You only subtract this and you obtain 520. C is 520. So what is the conclusion for this? You can read in the part below. 520 children's ticket and 280 adult tickets were sold on Saturday. Important, when we solve this system of equations and we have a study problem, they are asking you about something that happened. So you need to answer in words, like in here. You answer how many tickets for each one, okay? Because you name the variables. You say at the beginning that C was for children and A was for adults. So you need to know when you find the result, you say the answer in words. How many tickets for children and how many tickets for adult people, okay? This is the idea for this part. Then we are going to continue with the number 2. I think that we have time to continue with the second one. In the second one, we need to use substitution. to solve a system with no solution. This one is one solution, right? The first example. In the second one, we have no solution. And in the example 3, we have infinitely many solutions, but I think that for that example, I'm going to finish tomorrow because we don't have time enough. Okay, so we need to solve the system that appears in here. We read the problem. Seiko takes pottery classes at 2 different studios. Is there a number of hours for which Seiko's cost is the same at both studios? Okay, so they have different prices. You can see the information at the right part. Community pottery, studio and club, please come and join us. They give you the information that is $14 per hour. All clay included, all the clay for the, okay, for the manufacturing of these ceramics that they are going to do. You can see the drawing, the ceramics that they have. Okay, that's what they do on the club. And the other one, the private studio ceramics, it costs $28 per hour, plus $15 for clay. So in this, they sell the clay for the ceramics. You need to write the equations for the system. And later you have the equations, you solve the system and you identify why this doesn't have a solution. Or if it has one, you can say what is the solution, okay? Okay, so we are going to write the equations. I'm going to write this part. Okay. We have the system of equations. Y equal 14x, and the other one is y equal 1/2 multiplied by 28x plus 15. How you obtain this, guys? You can see that the first one is $14 per hour. So we represent x for the number of hours. We don't know the number of hours that they are going to be there. And for the other part of the equation is for the other studio, $28 per hour. Again, the number of hours x plus $15. The $15 are extra for the clay. And why we multiply by 1/2? Because they give you the information that if you go with this ticket, in the blue part below you see it, they are going to give you the half of the price, okay? Bring this coupon for half of the price advertised above, okay? So we multiply by 1/2. This is the system of the equations. Again, we need to replace the value for each variable in the other one. Y equals 14x, so I replace this. Y equals 14x. The idea of this is that with the both equations, with the two equations, sorry, we find just one and only with one variable. I don't want to work with both variables because it's too difficult. So I reduce this to work with only one. So I have 14x equal 1/2 multiplied by 28x plus 15, okay? And we solve this multiplying the terms. Remember what we have, guys, that this 1/2 is affecting all the numbers inside the parentheses, so you multiply 1/2 by 28x and 1/2 by 15x, okay? Sorry, 15 doesn't have x. Then we have 14x equal 1/2 multiplied by 28. The half of 28 is 14x plus 15 times 1/2. That is 7.50. I only multiply, guys. Since the moment you see this, that you have the same number with the same variable, this is going to eliminate, because if you have 14x minus 14x equal 7.50. I pass, remember, the numbers that have the same variable to the same side. And if I pass 14 minus 14, you are going to obtain 0x. So 0 is 7.50. This never could be the same, okay? 0 is not going to be equal 7.50, never. So this system has no solution because the statement is not true. We have something that is not true. I think that you remember about this in the second portion. And in the first one, we identify the system when they have one solution, no solution, or many solutions, only watching at the equations. Remember? Okay, so this is like a little review. So if you have something like this, you are not going to have any solution. Okay, so if the second example is clear, I think that we can finish in this part. Okay, I don't know if you have some questions about this. Okay. I'm going to finish the recording, guys. So